Hello, do you remember this electric bike that I put together a few years ago? I've been putting some work into improving this recently because I thought I might sell it, and in order to sell it I would make it a bit nicer, much nicer than I would do just for myself to use, and hopefully that would make it more attractive to a potential buyer. I ended up not really using this bike all that much, and the main problem is that the batteries that I had for it were LiPo batteries that I was also using for my drone and my planes and so on. And they're unprotected cells, and they need to be returned to a storage charge if you're going to be leaving them unused for a while. You can't just leave them depleted. So basically they're kind of high maintenance batteries, and you need to use a special hobby LiPo charger to charge them with. There's a whole lot of little things that needed to be considered when you're using those kind of batteries. So it made it a little bit difficult to sell because the average person doesn't want to deal with that. So as part of this improvement, what I wanted to do is make it to use lithium-ion batteries, which are a little bit more hardy. They can take a little bit more of abuse than the LiPo batteries can. And I also wanted to add a battery management system and possibly some sort of active cell balancing thing so that the cells would basically be foolproof, and just the average person taking control of this thing wouldn't be able to ruin it. And I also wanted it to run with a dedicated charger that you could just plug into the wall socket and plug into the bike, and you didn't have to deal with setting, constant current settings and all that kind of stuff. And basically just make the whole thing much easier to deal with from a day-to-day maintenance point of view. And along the way I also wanted to tidy up some other things, like the rear shock quite badly needed a service, the brake lines needed bleeding, could have used a new chain. Just things like that here and there that would just make this bike a whole lot nicer of a bike. So I've been recording a whole bunch of videos. I've done various things on this project. I actually started on this in August, and I've just been doing a little bit of it here and there. And it's starting to fill up my hard drive with video files now, so I want to make some space, and I'll just dump it all here for your viewing pleasure, hopefully. Okay, it's a couple of months later now. I have the bike pretty much all stripped down. Changed a few things there. You'll probably notice that the wheels have been replaced. Why on earth would I want to do that when I'm trying to just sort of spruce it up to sell it? Well, unfortunately, I discovered when I was looking at things that there's a fair bit of damage to one of these spokes here. I don't think that's repairable. And on the other wheel there were some telltale sort of cracks coming through in these little areas here as well. Where's my finger? Like that, so that yeah, I don't think those wheels were going to last much longer, to be honest. So I found some more. These ones, would you believe, are ½ kilo lighter as a set. So I put those on, and some new tires, so it's looking quite nice there. That's the easy part. And I'm just about to take this into town to the bike shop. This COVID-19 nonsense has been putting this off for quite a while, but finally I can go in and do it. And I'm going to get them to service the shock there, and also the front forks, and replace the jockey wheels, or the little pulley things on the back there, because they were looking a bit grotty, and a few other things. I'll bleed the brakes. I mean, I could do some of this stuff, but I thought I might as well just get the shop to do it while I'm in there doing the other stuff, save me the time and trouble. But anyway, the bike as a whole, whatever, is looking quite nice now after a bit of a clean up, and especially with those new wheels on. And the super clean cassette here looks quite nice too. So that little adventure cost me $700. Not to upgrade the shocks or buy new ones or anything, no. Just to service the ones I already had. And to put that in perspective, I paid $400 and something for this bike when I bought it. This is ridiculous. Is it just me? Why is it so damn expensive? To put that in perspective even more, you can buy a brand new set of 4 gas struts, shocks, for a Toyota Hilux for about that much. That is there, set of 4. Or if you want to get fancy, you can get some fancier ones for $560. Again, set of 4. It's just like, why are bicycle stuff so stupidly expensive? Somebody tell me. I'm using these Powerwall battery holders to make these into a 6S pack so that my RC battery charger can charge them up and balance them and everything. It's quite convenient. Just running another test here. Been going for 3.5 minutes. Started at about 6.6 amps and we're on 6.1 at the moment. Voltage is 3.62, and it's slowly trickling down at about that speed. And I have the battery in the holder here with a temperature sensor stuck on it, and over here we have the load. Getting pretty warm, and this is the temperature of the battery at the top there. I mean the sensor on top of the battery. This started at about 19 degrees 3.5 minutes ago, so you can see it's climbed up to heading for 25 about now. But in the last couple of tests I did, it didn't really get very hot, but I was only running at 5 amps for those ones. So 6 amps. I'm hoping to warm it up a little bit more. Yeah, you can just sort of start to feel that getting a bit warm. So overall I'm fairly pleased with these batteries. Just the few that I've sampled properly like I'm doing now, they've all performed pretty well. Okay, so I stopped that one at 30 minutes and the voltage got down to about 2.6 or so. And then over the next 8 minutes, the temperature cooled from the highest point that it got was 36 degrees and now it's down to 27. So that's with this much cooling availability, like it's like not touching anything, so the heat can just radiate all the way out, which is not going to be the case with this situation, especially these ones in the middle. So that's the main reason I was doing that test there, to see how hot it got at the 6 amps, which I'm hoping that the 6 amps is going to be the maximum that it's going to need, because 40 amps, the controller is supposed to limit the current to 40 amps. So if you divide that by 6 cells in parallel, you get about 6.6. That's the idea anyway. So I'm really hoping that that controller does actually limit the current like that. I haven't found a spec sheet for that controller, which is a little bit worrying, but I have seen people on forums saying that it does limit the current. So I should probably test that at some point as well, just to make sure it is. Okay, so at this point I'm ready to start doing the spot welding on this to make it into an actual 16S pack. But I thought it might be a good idea before committing to that, because I can still fairly easily dismantle it. I want to get used to how this BMS works, like the low voltage cutoff and stuff like that, and also this charger. So I thought what I'd do before doing that is to make a smaller pack using these other square things that I've got, and that's going to be 16S 3P, because the charger is 3 amps. So these are only supposed to be charged at 900 milliamps, so, or 1 amp roughly. So I need 3 of them to handle what the charging current is going to be putting out. So I can do that fairly easily with these. I've got a bunch of those, and since I have a bunch of extra cells, way more than what you see here, by the way, shouldn't be too hard to put together. And I also want to practice my spot welding a bit too. I put this together last week. This is the only spot welding I've done so far with the welder since I got it. And this was really, really easy, but this is nickel-plated steel, which apparently is quite a lot easier to weld than the pure nickel stuff that I'm going to be using on the actual pack. So I want to get used to all that stuff before I commit to doing the real one. Okay, so here's my 16S 3P pack for testing. It's not going to win any beauty prizes, but it doesn't need to. It's just just temporary. And I put some 4S LiPo balance plugs along here like this, so that I can use one of these LiPo alarm checker things just to have a look at what's happening a little bit easier. Okay, I'm just trying the charger now, and it's pretty much 3 amps like it's supposed to be. It's a little bit noisy. It's got this fan there that's going the whole time as soon as I plugged it in. Okay, I'm going to do a full charge now, and I want to see that it doesn't let any of the cells go over 4.2 volts. Okay, so the current has just dropped down from 3 amps, which was the constant current phase, and it dropped a little early, so 67.2 should be the full voltage. That's 16 times 4.2. And over here we see none of these are exceeding 4.2. Well, there's only one that's close to it. What's that? Okay, the next thing I was going to say is that these little voltmeters I have, these are the ones that I made myself. Unfortunately, they're reading a little bit high. When I actually checked the voltage of that cell, it was a couple of hundreds less than what it's showing on the screen, and likewise for this one as well. Okay, so the charger just turned off, fan turned off, it's all quiet now, current dropped to nothing. These didn't really all come up to 4.2. Well, they were showing 4.2 just when it turned off, close to it. This one was all 4.2 pretty much. And overall pack voltage 66.2. So I think, I wasn't closely watching it the moment that it turned off, but I think it would have been just hitting on to 67.2, which is what made it turn off. So I let it sit for a while, and then I reconnected the charger because I wanted to be watching it at the moment that it turned off to see what the voltage was over there and what the lowest current was that it was pushing at the moment when it turned off. But interestingly, as soon as I connected it, it decided that it's already charged. The balancing I'm not so impressed with, because if the charger cuts out early, these don't really get high enough for the balancing feature of the BMS to kick in. So overall, each of these things is doing what it should, but the interaction between the two of them is not really the greatest situation. So I've actually just purchased an active balancing board, which I'll be using with this instead, if it works out nicely. I'm not sure if I'll use this as well. I don't see why I couldn't use this and the active balancing board. But yeah, I'd rather see these cells balanced nicely. The alternative is to leave these 4S things on, and whoever buys the bike could periodically use a regular RC LiPo charger or something to balance them nicely every now and then, and just do it that way. But it kind of goes against my goal of making it easy for the average person to use. Okay, now I'm doing a discharge test to see where this BMS cuts the power. I'm discharging it about 2 amps or so. I can't really get it much higher than that because there's no load on the motor, and it seems like that's about all it does at close to full throttle. I was fiddling around with this before, and I think I might have broken the hall sensor or something because it's not working. So that's alright though, because I had to replace it with this anyway for convenience. This is just a regular potentiometer, so that's performing the function of the throttle, and that means that I don't need to hold this, like make something to hold that in a certain position. Okay, it's a couple of weeks later now, and I've received some extra things in the mail that will help with this project. I didn't really finish that discharge test because it was just taking so long, so I just let it get to the point where it was about half charge, and I mean like storage charge, and I left it like that. It took, well, I left it running for about 5 or 6 hours, and it just spinning this with no load, and it was getting a bit hot actually, so I had to bump it down to 1 amp. So it was 6 hours at 1 amp, and yeah, still I just couldn't be bothered waiting. It was kind of noisy too. Anyway, so what I got in the mail is a couple of these 8S battery checkers, but they're 8S plugs, so to use them I got some of these 8S, they're just like extension cables, and I'll replace these 4S ones that I've got on here with the 8S ones. And I got this here, which is an active balancer. A little bit pricey these, so I didn't really want to get one. This was about $60 US. But what's nice about this is it will balance the cells properly no matter what level of charge they are. Well, there are limits of course, but it doesn't only balance at the top of the charge like this one does. The maker claims that this will stop balancing when the cells get to within 5 millivolts of each other. So in theory it shouldn't be drawing any power all the time, only when the cells are out of balance. But I'm not sure about that, because I've seen people on some forums say that they just sort of balance all the time in their experience. So I think to connect this I will use this side of my balance plugs, which is that one, and instead of using these horrible big bulky connectors that they give you, I'll just solder those LiPo connector things on there like that, and that should make this balancer quite easy to connect and disconnect if I don't want to use it later. And another thing I got here is a throttle. This is a Hall Effect throttle, the same as I had before, but this one works. Got this from Australia of all places. It only cost $8 too, which is quite cheap. But like I said, this one over here, I did something to it and it's not working anymore. The throttle part of it doesn't work, at least. So I've just been using this as just the switch only. But I think what I'm going to do is just ditch this completely and replace the switch part with this, which I got on Trade Me. This is for a pit bike, little motorbike, and that's just the ignition kill switch, 2-position switch. So that'll replace the key, and then there's a little voltage readout here which is quite handy to see the overall voltage of the pack, but it's starting to get very weak and dim over the years, and some of these segments, it's a 7-segment display, some of the segments are not showing up properly either, so it's kind of getting useless at the moment. So I'm going to replace that with a separate voltage display which is going to go in the middle of the handlebars. Ooh, look at that. 560 milliamps, 700 milliamps, 666, only 52 milliamps there. But it looks like it's doing the job, so, oops, I'm supposed to start my stopwatch. So let's come back in a few hours. Alright, it's now about 36 hours since I started running this balancer thing. And it's actually gone up a little bit to 23, 22 millivolts on that one, 25 on that one. And you can maybe see the yellow of the lights on the back of the board there still going. So yeah, I was thinking it would probably be finished by now. But what I'm going to do now is I want to test discharging, but I'm not going to do it by running the motor. I built this other thing here, which is this is 10 1 ohm resistors in series, so it's about 10 ohms, or by the time you've got all the wire and everything on it, when I measured here with my ohm meter, it was 16 ohms. So with 70-ish volts, so at a full charge that'll be 67 volts on this pack. That should give me something like around about 7 amps, or less than 7 amps I'm hoping. And each one of these is 50 watt resistors, so it could be up to around 500 watts. And 10 50 watt resistors is 500 watts of dissipation. And then I've put these big aluminium angle heat sinks things on there as well, like that. Okay, a bit over 5 amps. So this is 59 volts at the moment, the pack was. This is way better than running the motor. For one thing, I can get 4 or 5 times as much current. It doesn't make any sound, and also it doesn't put any extra wear and tear on the motor and the bearings and everything just from having it running for hours and hours. So it took me a while to put this together, but I'm glad I did. Ooh. Yeah. I think we'll be alright. Unfortunately, it ended up not being completely silent because I had to put the fan on it to keep it cool properly. It's funny, it's like too hot to touch here, and then from about here it's not much more than ambient temperature. Well, it looks like the BMS has turned off the power, but we're only at 3.25 volts per cell roughly. I'll have to do a little bit more experimentation and find out exactly when it stops it. There, it stopped. Okay, I left this overnight again and it's still got both LEDs going. And we've got to 15, 16 millivolts on this side, and also, oh, a little bit better on this one. The best I've seen so far is 12 millivolts, which was a couple of hours ago. So I just get the feeling it's not really going to make it to 5 very quickly at all. and the voltage on these cells is starting to get a bit low now, so I think from this point I'll just do a full charge. Okay, well this is looking pretty good. The cells that are going over 4.2 volts are not going over it by much. Like 4.205 was the highest I saw here, and doesn't seem to be like increasing, and the current is steadily decreasing. So yeah, this seems pretty good. Just finished charging there, and the fact that we still see a voltage here means that it was not the BMS that stopped the charging, because if that was the case we'd see 0 here because it would disconnect the battery, I think. Over there, a green light. So I'm pretty sure that was stopped by the charger and the BMS didn't really do anything. So the voltages did go a little over 4.2 here, so we've still got a 4.212 on cell 4. Actually, quite a few of them are over 4.2 volts, aren't they? Oh, what about this other one? Yep. Hold on a second, I just noticed that there's still half an amp coming into the battery, so maybe... Why did the fan turn off and the light go green then? Okay, so if you leave the charger connected, it does steadily decrease the current very slowly. It's been about 10 minutes, it's gone down to 360 milliamps there. I just looked up the web page for where I got this charger from on AliExpress, and it says it has 3 modes: constant current, constant voltage, and trickle, which is probably what we're seeing now. But I don't think we really want a trickle, do we? While I'm watching this, I'm realizing that this slow trickle at the top of the charge is actually quite useful if you have a BMS that's trying to dissipate charge from some cells, but it can only do it slowly. So the BMS that I'm using, I think it can only handle a 50 milliamp, like the cells that are too high, it just wants to reduce them a little bit, but it can only do that at a maximum of 50 milliamps. So if you only have something like, what do we got here, 70 to 80 milliamps coming into the whole pack, then the BMS could actually keep up with discharging fast enough to balance the cells at the top of the charge quite nicely. So maybe it's not such a bad thing after all, but it depends on all of the cells reaching the top of the charge at approximately the same level, which is where this really comes in. Okay, I've now completely disconnected the battery checkers, and it seems like that was necessary to let it fully get to the 67.2 volts that it's looking for, and then it will completely drop the current to nothing when it gets to about 60 milliamps, at least on this measurement. So it's probably more like 50 is the actual setting that it's set to. See, it's gone to nothing, but watch this, it'll turn itself back on again after a few seconds, and it just sort of seems to repeat that process. So I'm still not sure if this is what we really want. And I certainly don't like the fact that the trickle is operating in this very, very high range. So what I'm going to do now is what that's the total voltage. What I was planning to do all along anyway is to open this up, and I want to see if there's a trim pot in there somewhere that I can twiddle with a bit, so that the overall final voltage that it's looking for, instead of being 67.2, is more like about 66.4, I think was what I wanted. And that should charge each cell up to 4.15 volts. And I read somewhere that if you just decrease that highest voltage point by a little bit, you can get much more longer life out of the cells overall. Okay, opened this up, and there are indeed some trim pots in there. 3 of them actually. Not sure why there would be 3. But anyway, rather conveniently, all you have to do is connect your voltmeter up to the output there, and it looks like it's just going to sit on whatever the target voltage is. Well, that was easy. So if anybody else has one of these chargers and they want to change the target voltage, be careful of course, because it's plugged into the mains there. You don't want to drop your screwdriver into there while you're doing this. But of these 3 potentiometers here, it's the one by itself on the left there, that one there, and if you turn that clockwise it will decrease the voltage. So I've set that to 66.24, which for a 16 cell pack should give me about 4.14 volts, or probably a little bit less than that, but that's what I'm going to go with. And that kind of makes me wonder if I can also change the charging current. But anyway, I have to discharge this pack a little bit now before I can charge it up again and fiddle with the current setting. Hi, 6. Wow, it drops quickly, doesn't it? So it was only about 6 amps there. Alright, so probably pushing about about 420 watts or so. So it's going to get hotter than yesterday, but not by much. Well, what do you know? The left hand one of these pots here can be used to adjust the current. And I've managed to get it down to 1 amp. Might be able to go a little bit less, but 1 amp is about what I would have charged a single cell like these anyway. So if I had have known that, I probably should have checked earlier. Actually, no, I couldn't have checked earlier because I needed to be able to run this at 3 amps first, didn't I? Oh, anyway, now that I know, I didn't need to have a 3 parallel cell pack for testing. I can just do it with 1 string of single cells now. Okay, I charged this pack up again, and it's actually been about 4 or 5 hours since the light turned green, and it seems to have settled on about 50 milliamps. And the cells are kind of approaching 4.15 but not quite reaching it. So everything looks exactly like what I want. Well, I've had this pack sitting here like this for about 8 or 9 days now. It's been at least a week anyway. And you'll see here that the voltages have gone down from the 4.15 or so that they started at to about 3.6. So we've lost quite a lot of charge in that week just from, well, there's actually 3 things connected. So this has been connected. This has probably been taking most of the charge out, the balancing thing, and hasn't stopped. And we've got, the closest I've ever seen is, I was going to say 12, but 11. Okay, 11 is the closest I've ever seen then. But it just doesn't finish, even after such a long time. We had this connected, that probably wouldn't be using much power. And these have been connected all the time as well, but they go to sleep after a while, so they wouldn't have been using that much energy, I don't think. So it's probably mostly this that's been knocking that voltage down over the week or so. So it looks like this is the kind of thing that you would not want to have permanently as part of the battery pack. I've started to revise my plan for what to do here. I'm thinking at this point that maybe I'll just make the pack with none of the stuff in it permanently. So even that, I'll leave that out. I'll leave that out. And the pack's just going to be the cells wrapped up in the heat shrink, and then I'll have these 2 8S balance connectors sticking out of the pack with nothing connected to them. And what's going to happen is when you ride the bike, I'll probably have to include these 2 things simply for the purpose of a voltage alarm, because they have quite a wide range of voltages you can set here. So there's a low voltage alarm there, it goes all the way down to 2.5 volts if you want to. And there's also an option for the alarm tone to be repeated. Unfortunately, it doesn't repeat it very quickly, it's only every 60 seconds or so. But between that and the fact that there's 2 of them as well, so they'll both be going off, and also on the handlebars, like I said, there'll be a voltage display so the rider can see how the voltage is going, and they'll have an idea of when they're getting to the end of the charge anyway. So this will just be an extra sort of a alarm, and this will not be included anywhere. There's one thing I need to check though, and that is that the ESC here, if this actually does limit the current to 40 amps. I want to check that. If it does, then there's really no purpose to have this anymore. And then this would also not be connected to the battery permanently. So this you would just leave at home, or you could leave it, I guess, maybe with your charger, wherever you have your charger, because you don't need to use this very often, maybe once every 5 or 6 charges, say, or like once a month maybe, if you don't use the bike that much or whatever. So yeah, what you would do is you would ride the bike, and then when you get home and charge it, or every so often, you would just connect this up while you're charging. And then when the charge is finished, disconnect that, or maybe let it run for another day if you want to. And then if you're not using the bike, just disconnect everything from these 8S connectors. And I think that will be fairly safe. So it does require the user to do a little bit more effort than I was hoping for with my original plan. I was hoping to make this like for dummies, anybody could just plug it in and charge it and forget about it, and they didn't have to think about any of the stuff. But I think I might have to make a compromise. Just had a nasty shock, and I'm not talking about the electrical kind. I'm about 3/4 of the way through welding this pack, and I started off by doing the parallel connections like that, just using nickel plated steel, because when I bought this welder, this is the welder that I got, by the way, just in case anyone's interested, seems to work quite nicely. With that came some like sample pieces that you could like play around with, and they are nickel plated steel, and they're just the right length to do 6 cells like that. So I was okay with using nickel plated here because this isn't going to be carrying much current. But then for these ones here I wanted to use pure nickel, so for that I used some other stuff that I bought on Trade Me a couple of years ago, and then I ran out of that. I managed to do the whole back side, the underside of the pack with that, so I bought some more again on Trade Me, and I'm just doing the front side here. But I noticed with the new stuff that I got, it was a lot harder to weld, and it was also quite a bit softer. So I got out my little Dremel, which if you grind away at this, you can either get sparks or not get sparks, depending on whether it has steel inside it. So this is the one, I just used a little cut-off wheel, so you can see with a little bit of pressure it actually cut through there, and there were no sparks there. But with this stuff here, which I was using yesterday, with about the same amount of pressure, it didn't cut through, and there were some sparks coming from it. So you can also see it's kind of like a little bit hard to keep it focused there, but you can see that it has a surface layer that's different from the inside. So that was quite disappointing, because the issue with it is that there's about 10 times as much resistance in the steel than in the nickel, pure nickel. So if I do the calculations, and assuming I can get the whole 40 amps at full throttle that I'm hoping for from this pack, that's going to be a difference of about 250 watts wasted using plated versus 25 watts wasted using just the pure nickel. That's at full throttle, so you're not going to be doing that very often, and the power scale's at P equals I squared R. So it's not a linear curve. So at lower throttles, say like if you're only doing 10 amps, then it's not anywhere near as much power being wasted. But still, since I've caught it early, well, I'm about 3/4 of the way through this welding now, but since I've caught it at this stage, I'd like to do something about it, and ideally I'd probably pull all the connections off the back and replace them with the pure nickel, but that seems like quite a bit of work. So what I might just do is put pure nickel in between the plated nickel like that, so that we're just going to have a massive big lump of connection between the series connections. And on this side, which I already have the pure nickel, I might put some of the plated nickel in between them on this side, so that it's about a 50-50 mix of pure and plated on each side, just so that it doesn't get too unbalanced. Yeah, so that's quite annoying, but having been caught out by that once now, I will not be caught out by it next time. So the normal connection between a series set of cells is to do 6 connections like that. So these should be able to handle 10 amps each fairly easily. But at this halfway point where the series comes down and goes back up again, we can't really do that so conveniently here. But what you can do, I saw a tip somewhere, is you can build up layers of this like that, so that you can connect these two, and then those two, and then those two. You could also do it with just a big piece of wire across here, so that the 40 amps could go through a thick wire right here. But you need to sort of solder it all the way down like that to make sure you're not trying to pump. Well, actually, you only need to go to the second to last one, don't you? Because you can still get the 10 amps out of that one. But anyway, this is a easier way to do it. No soldering, and it also keeps everything a bit slimmer and flatter than if you were soldering a wire on there. Okay, so I managed to put together a 16S 6P pack without setting anything on fire, and I'm just deciding what to do about these series connections here. I thought I should at least have a go and see how difficult it is to remove them, but like I said, the steel was a lot easier to weld, so unfortunately, or fortunately I guess, the connections are very, very secure, and I couldn't really see myself pulling all these off to replace them with the pure nickel. And they don't really need to come off, they just need more current carrying capacity added. So what I could do, my idea about putting another bridge in between them, like from here to here, that's not going to work, because I tried that just briefly when I was joining this bit, the halfway point on the other side, and what happens is this plastic honeycomb stuff that's holding them together just vaporizes, and you get a puff of horrible smelling plastic smoke. Plus, when you're pushing on it like that, it sort of sinks in a bit, and I don't want to let the welder get anywhere near the rim of the positive sides. So I think that's a no-go. You can't really put anything in between here with this plastic honeycomb stuff that I'm using. So what I think I will do, I'm going to put this aside for a bit because I don't have any heat shrink to cover it, and so I'm waiting for that to arrive, and a couple of other things, so I'm not going to do any more on it now. But what I'll probably do is I'll order some more of this pure nickel, now that I know where to get it from, and I'll just put on the screen here the seller on Trade Me that I got the pure nickel from, for anybody who's interested. And I'll just come back at some point in the future and I'll put pure nickel right over the top of this. It's not ideal because it's going onto the steel. Ideally you'd want to have the nickel closer to the bottom, I think. But what that will do is it'll give me like a doubled connection on all of these like that. And my calculations that I mentioned earlier were wrong, because I was forgetting that I have 6 connections in parallel, so it's not going to be wasting 250 watts for the nickel plated ones. It's only going to be about 40 watts at full throttle. Still quite a bit. If they were all pure nickel, that would only be about 4 watts wasted. If they were half and half the way they are at the moment, one side is pure and one side's plated, if I just left it like that, I'd be wasting around about 22 watts at full throttle. But if I do what I was just mentioning, and I come back and I put pure over the top of the nickel, pure over the top of the steel, and steel over the top of the pure, so they'll all be exactly the same, and they'll be like doubled up, which is what I'm calling all both. That would actually only be wasting 3.8 watts at full throttle. And these numbers, like I say, it's not linear, so if you halve the current, you quarter the wattage wasted. So at 20 amps, or maybe like a more reasonable long-term cruising current, you'd only be wasting 10 watts in the worst case, or quarter of that, which is like 1 watt for cruising. So that's actually not as bad as I was thinking. I have some other numbers down here which are the settings that I was using. I found I had to change those. So this one that I'm calling current at the top is what this thing calls current there, set current. So it's at about 7.6 or so on that one. And these numbers here, which you can change, not sure what this is, pulses I think? Oh yeah, pulse. So it doesn't actually change right after you change that button, but if you push the pedal, you'll see it changes to whatever you had selected. I'm not sure why it doesn't change straight away. But anyway, so if you put 4 and 8, then you get 12. So anyway, when I was putting the steel straight onto the cells, I was using 6, and that everything worked very, very nicely with that. Putting the pure over the plated was when I discovered that I was using the wrong material, and I had to bump it up to 12. And I also found that when I tried to put the pure nickel onto another pure nickel, as I was doing with the long bridge across the bottom there just before, that needed quite a bit more. In fact, probably more than the 12 that I've written there, but I was using 12 and it kind of did it okay-ish, I think. So that's going to do it for this video. It's getting way too long, isn't it? This here, by the way, is a temperature sensor, which is like right in the middle there. And for the time being, it's just running on this Arduino, but I might figure out something a little bit better for that later on, and that's going to have an alarm based on just temperature if it gets too hot. Anyway, thanks for watching, and in the next video I'm going to redo the box that this battery is going to go in. So until then, thanks for watching. See you next time.